Hi, good evening. Last class we were discussing about homogeneous type of differential equation. Apart from that, we also discussed non-homogeneous. We also discussed non-homogeneous type. I told you non-homogeneous type we are classifying into two. Number one, dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash, where a by a dash is equal to b by b dash. We discussed this type last class. Type 1 under non-homogeneous differential equation. Here ax plus by plus c is a non-homogeneous expression in the numerator as well as the denominator. This comes under non-homogeneous type. At the same time, if a by a dash is equal to b by b dash, if this condition is satisfied, we call this as type 1 under non-homogeneous type. Now, today we will discuss type 2. We will discuss type 2 under non-homogeneous type. That is, dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash, wherein a by a dash is not equal to b by b dash. If a by a dash is not equal to b by b dash, we will reduce this non-homogeneous to homogeneous by proper substitution. After that, as usual, we solve. Let us see. Let us illustrate with an example. Let us illustrate this with an example. For example, dy by dx is equal to x plus 2y minus 7 divided by 2x plus y minus 3. Okay, let us discuss this problem. I have taken this problem at random. Now, a is 1, b is 2, c is minus 7. A, B, C. In the denominator, a dash is 2, b dash is 1, c dash is minus 3. We observe that a by a dash is 1 by 2, b by b dash is reciprocal, 2 by 1. They are not equal. Here, we see that a by a dash is not equal to b by b. We want only this condition. If this condition is satisfied, it comes under type 2, non-homogeneous type. Now, if a by a dash is not equal to b by b dash, we make use of substitution. We make use of substitution like this. In such a way, this reduces to homogeneous type. Now, we are giving substitution. X is equal to capital X plus H, where H is a constant. Y is equal to capital Y plus K, where K is a constant. Here H and K are constants. When X is equal to X plus H and Y is equal to Y plus K, automatically dy by dx becomes d capital Y by d capital X, because H and K are constants. We are choosing H and K in such a way, this, when substituted here, reduces to homogeneous. Let us see how. So dy by dx is d capital Y by d capital X. I am substituting for everything. X is x plus h. 2y is 2 times y plus k minus 7. 2x is 2x plus 2h plus y. Y is y plus k minus 3. Yes. Now we are choosing h and k in such a way. We are choosing h and k in such a way. H plus 2y, h plus 2k minus 7 is equal to 0. That is h plus 2k minus 7 is equal to 0. That is all constant terms become 0. Here 2h plus k minus 3 is equal to 0. We are choosing h and k in such a way. H plus 2k minus 7 is 0. Constant terms I am equating to 0. 2h plus k minus 3 I am equating that to 0. Then automatically you get d capital Y by d capital X as x plus 2y divided by 2x plus y. Because we are equating all constant terms together to 0, we find h and k accordingly. Now for that I am doing it here so that you can have a very good understanding. Now see here, multiply the first equation by 2, you get 2h plus 4k is equal to 2 times 7, 14. You write 2h, second equation as it is, plus k is equal to 3. Subtracting, you get 3k is equal to 11. Therefore, k is equal to 11 over k is equal to 11 by 3. When k is equal to 11 by 3, we can find h. H is equal to, from the first equation, 7 minus 2k. 7 and 2k is 22 by 6. So 6, 7, 42, 42 minus 22, 20 by 6 or 10 by 3. So therefore h is 10 by 3, k is 11 by 3. When h and k are chosen as 10 by 3 and 11 by 3, you write it here, h is 10 by 3, k is 11 by 3, automatically this equation reduces to homogeneous equation like this. This equation reduces to homogeneous equation dy by dx is equal to x plus 2y by 2x plus. Because if you substitute h is equal to 10 by 3 and k is equal to 11 by 3, all constant terms will disappear, and automatically in the denominator also all constant terms will disappear, giving us only x plus 2y, x term and y term. Therefore, equation becomes homogeneous. So therefore, we are writing that homogeneous equation. So that homogeneous equation is d capital Y by d capital X is equal to x plus 2y by 2x plus y. Now, once the equation reduces to homogeneous type, we can make use of the substitution y is equal to vx. You know this, we have discussed this already in last class. Y is equal to vx, we are able to solve this homogeneous equation easily provided it is homogeneous, not of any type. Therefore, dy by dx is nothing but v plus x into dv by dx, is equal to x, y, 2y is 2vx divided by 2x plus y is nothing but vx. Therefore, x into dv by dx is equal to x gets cancelled, giving us 1 plus 2v by 2 plus v, I am bringing this v that side, you get minus v. You get minus v. So therefore, because we require all these things, we require h, we require k. So h 10 by 3, 11 by 3, everything we require. That's why I am not erasing completely. Now, what happens? You take a 2 plus v LCM. X into dv by dx is equal to, you take 2 plus v LCM, you get 1 plus 2v minus 2v minus v square by 2 plus v. You separate the variables v and x, therefore cross multiplying, we get v plus 2 v plus 2 by 1 minus v square dv is equal to dx by x. We are able to get a very simple differential equation in v and x. Variables are separated. It's very easy for us to integrate this integral, right? So therefore, we are separating this into two integrals. V by 1 minus v square dv, one integral. The other integral is 2 times 1 by 1 square minus v square dv is equal to dx by x. Very simple integral we are getting. Now, differentiating v square you get 2v, 2 is missing, and minus 2 is missing because we differentiate minus v square you get minus 2v. So what we do is minus half of integral minus 2v by 1 minus v square dv. So this 2 gets cancelled, minus sign, you get a plus v. So here this can be integrated easily without any difficulty. dv by 1 minus v square is equal to dx by x. dx by x. Now we are ready for integration. We can easily integrate and we can easily get the answer immediately. Okay, now differentiating denominator we get numerator. Therefore, integrating this you get minus half of log of denominator, because numerator is exactly division of denominator. This is in the form dx by a square minus x square. So 1 by 2a, 1 by 2 into 1, I will write it here because instead of writing here, I write it at the top. That will be convenient for me. So therefore, minus half of log of 1 minus v square, half of log of 1 minus v square, and this is in the form dx by a square minus x square. Therefore, 2 times 1 by 2a, a square minus x square log a plus x by a minus x. Here a is nothing but v, variable is v, that is equal to log x plus some constant. Log x plus some constant. Integral 1 over x is log x. So now we are getting a solution. This is a relation connecting v and x, and where v stands for where v is equal to y by x, capital Y by capital X, because y is equal to vx we are given. Where capital Y is nothing but y minus k, and the capital X is nothing but x minus h, which is nothing but y minus k is 11 by 3, and h is nothing but 10 by 3. Therefore, wherever you find v, here v square is y minus 11 by 3 whole square by x minus 10 by 3 whole square. Log 1 plus v, this is v, by 1 minus, this is v, log x, x is x minus h. Substituting for y, x and v, these quantities, we are getting a solution. This is the solution of the given differential equation, which comes under non-homogeneous type. I repeat again, we are reducing non-homogeneous type to homogeneous type by introducing x plus h, y plus k. We are choosing constants h and k in such a way that constant terms totally disappear in the numerator as well as denominator. Thereby, we are able to reduce it to homogeneous. Once you are getting homogeneous, y is equal to vx is the substitution, and thereby we are getting a very simple integral. Integrating, we are getting the solution where v is replaced by y x, where y is replaced by y minus k, x is replaced by x minus k according to the given substitution. So this gives the solution of the given differential equation, which comes under non-homogeneous type. Okay. Now we are able to solve homogeneous, non-homogeneous type 1 and type 2. I think this example will do. You can easily understand. Try to solve many problems under that. Now so far under first order differential equation, we have seen variable separable. Number 1. Number 2, homogeneous type. Number 3, non-homogeneous type. And 4, we are coming to linear equation. We are getting linear equation. After that, we go to Bernoulli's, then exact. All are important for competitive examination. So therefore, we are discussing linear equation first. After that, we take Bernoulli's, and then we'll take exact. Okay, now we'll take linear equation. What is linear equation? A differential equation of the form dy by dx plus py is equal to q. A differential equation of the form dy by dx plus py is equal to q, where p and q are functions of x are constants. Functions of x are constant. It is not a function of y. P and q are functions of x are constants. Here x is the independent variable, y is the dependent variable. We get dependent variable here. Here p and q are functions of independent variable. That is very important. We call this equation as linear. We call this as linear in y. So therefore, in linear equation, we get an equation of the form dy by dx plus py is equal to q, where p and q are functions of x are constants. P and q are functions of x are constants. Similarly, we can also have linear equation in x. That is, if you consider dx by dy plus px is equal to q, where p and q are functions of y are constants. Then we call this as linear in x. We call this as linear in x. Now linear in y, linear in x. Here x is the dependent variable, y is the independent variable. We can have linear equation in y or linear equation in x, provided this condition is satisfied. P and q are functions of x. Here P and q are functions of y are constants. Like that, you can write down the solution directly, provided you understand the methodology behind it. Okay. Now the methodology is, as such, left hand side is not an exact differential. What we do is, we are multiplying each and every term. By the integrating factor, e power integral p dx. We multiply each and every term by this. Thereby, our left hand side becomes exact differential that can be integrated easily. Similarly, we are multiplying right hand side also by this e power integral p dx. And automatically integrating both sides, we get a solution as y into e power integral p dx. That is integrating factor. is equal to integral q into, that q is there, q is a function of x, e power integral p dx, dx plus. How this is obtained? I repeat again. We are multiplying each and every term by e power integral p dx. By doing so, left hand side, two terms, you can write a d by dx of this. We can easily verify that. Integrating, we get only that. So that is exact differential. We are converting left hand side into exact differential. Integrating, we get only this. And automatically right hand side, integrating with respect to x, we get q e power integral p dx is there. Integrate with respect to x plus c. So this gives the solution of the given differential equation, which is linear in y. Suppose you have linear in x, dx by dy plus px is equal to q, where p and q are functions of y, are constants. P and q are functions of y, are constants. Y means independent variable. Solution is, or integrating factor is e power integral p dy. E power integral p dy, where p is a function of y, we can integrate. The solution will be, the solution here, x into e power integral p dy is equal to integral q times e power integral p dy plus c. This is the solution. We have to integrate this carefully with respect to y, we get a solution. We can get linear equation in r, linear equation in theta, in linear equation in any dependent variable you can get. For example, if you have dr by d theta plus pr is equal to q, where p and q are functions of theta are constants. Functions of theta are constants. So in that case, accordingly we can write down the solution. Integrating factor, sometimes they may ask only integrating factor, e power integral p d theta, because p and q are functions of theta are constants. The solution will be r e power integral p d theta is equal to integral q times e power integral p d theta. We are integrating this with respect to theta as a constant. This gives the solution. So therefore, anyhow, whether you have linear equation in y, linear equation in x, linear equation in r, linear equation in theta, any variable if you have linear equation, once you understand this concept, p and q are functions of this independent variable. Locate that. Once you are able to locate, solving problem becomes very simple. Okay, to start with, I am starting one simple problem. I am starting with a simple problem. Dy by dx plus py is equal to q. Dy by dx plus py is equal to q. You need not take separately p and q. Here p is cot x, q is 4x cosecant x. If you mark like this, automatically the quantity inside p is p, the quantity inside q is q. So that is understood. Therefore, our integrating factor will be, this is linear equation in y, because p and q are functions of x alone. So integrating factor will be e power integral p dx. That is e power integral p is cot x. That is e power log sin x. Integral cot x is log sin x. Because differentiating log sin x, 1 by sin x cos x is cot x. Therefore, we get log sin x. We know one property. That property says e power log of, it's a property of logarithm. F of x is equal to f of x. e power log fx is equal to f of x. E power log of f of x is equal to f of x. If you have log e fx automatically to the base e, that's understood. E power logarithm of any function to the base e is that function. Here e power log sin x is simply sin x. According to the property of logarithms. According to the property of logarithms. Now, once you know integrating factor, I am writing the solution directly. That is y into e power integral p dx. That is y sin x. If you want, you can write down the formula and substitute. That is equal to integral q. Q is 4x cosecant x. 4x cosecant x into e power integral p dx. That is sin x. We integrate with respect to x. Add one constant. Sin x cosecant x gets cancelled. So we are left with y sin x is equal to integrating x, you get x square by 2. Already 4 is there. You get x square by 2. You get 2x square plus 2. So this is the solution of the given differential equation, which is under linear type. Because we are able to get the equation, we are able to convert the equation to the form dy by dx plus py is equal to q, where p and q are functions of x alone. It can be constants also. P and q can be constants also. Integrating factor is e power integral p dx. P is cot x. E power log sin x. Integral cot x is log sin x. E power log fx is the function. So therefore, y e power integral p dx is y sin x. Q e power integral p dx is sin x dx plus q. Therefore, simplifying this, integrating this, you get 2x square. Because x square by 2, 1, 2 gets cancelled. We get 2x square plus 2. Now, you can easily verify whether your solution is right or wrong. You differentiate y into cos x plus sin x into dy by dx is equal to 4x plus 0. You divide by that quantity. If you make dy by dx coefficient 1, divide by quantity, you get exactly this differential. So I repeat again, to verify the solution, to differentiate this, and we are getting the coefficient of dy by dx as cos x. Divide by cos x, automatically we are getting the answer. So therefore, we can easily get the solution also. Next problem. 1 plus x square dy by dx plus 2y is equal to e power tan inverse x. Now to convert this as a linear equation in y, you must get rid of this coefficient of dy by dx. The coefficient of dy by dx must be unity. Therefore, divide by 1 plus x square. Therefore, we are getting an equation dy by dx plus 1 by 1 plus x square y is equal to e power tan inverse x by 1 plus x square. We are dividing each and every term. By 1 plus x square. Therefore, automatically this term becomes p. This term becomes q. This term becomes p. Quantity inside q is q. The quantity inside p is p. Therefore here we have p is 1 by 1 plus x square. Integrating factor is e power integral p dx. That is e power integral 1 over 1 plus x square. Or in other words, e power, you know this is nothing but integral tan inverse x, integral 1 by 1 plus x square is tan inverse x. Therefore, you get e power tan inverse. E power tan inverse x. E power tan inverse x is e power tan inverse x. We cannot convert as tan inverse x. e power log of tan inverse x is tan inverse x. Here as such we write. We don't simplify. E power tan inverse x as such we write. Now, once you know the integrating factor, directly you can write down the solution. Directly you can write down the solution. The solution according to the formula. Solution according to the formula. Y into e power integral p dx, that is e power tan inverse x, q times q is what? E power tan inverse x by 1 plus x square. Again, e power integral p dx is e power tan inverse x. E power tan inverse x dx plus c. I repeat again. Y e power integral p dx is equal to q e power integral p dx plus c. So therefore, we are having a very simple integral in the right hand side, which can be integrated without any difficulty. Now see here, in the right hand side we are having tan inverse x 1 by 1 plus x square. This suggests substitution. Directly you get t is equal to tan inverse x. You get t is equal to tan inverse x. Therefore, dt is nothing but 1 over 1 plus x square, 1 over 1 plus x square dt. Therefore, y e power integral is tan inverse x. No integral here. Tan inverse x is equal to e power t whole square, that is e power 2t dx by 1 plus x square is dt plus some constant. That is y e power tan inverse x integrating e power 2t by 2 plus c is e power 2 times tan inverse x by 2 plus c. So this is the solution of the given differential equation. E power t plus t, e power 2t. So therefore, e power, or you can also write this as e power tan inverse x whole square. Both are same. So we can write like that. So ultimately, we are getting a solution like this. Now I will give one example in which we get a linear equation in x. X plus 2y square dy by dx is equal to. In fact, if you treat this as linear equation in y, you cannot treat, because if you divide by x plus 2y square, you cannot get p and q. You cannot get p and q. You will be struggling to find a p and a q. To avoid that, it is possible for us to convert this as a linear equation in x. For that, you just cross multiply. X plus 2y square is equal to y into dx by dy. Y into dx by dy. To convert this as a linear equation in x, coefficient of dx by dy must be unity divided by y. I am writing dx by dy is equal to x by y plus 2y. I repeat again, you cannot convert this as a linear equation in y. Even if you divide by x plus 2y square, y by x plus 2y square, you cannot get p, you cannot get q. Therefore, subject to the condition p and q are functions of x. No, not possible. For that, you just cross multiply. Y times dx by dy is x plus 2y square, or dx by dy is x by y plus 2 by y. Therefore, dx by dy minus 1 by y x is equal to 2. So what do you see here? This is a linear equation in x, where p is nothing but this one, along with the negative, and the q is this. Negative sign is included. If you want, you can write minus 1. So p is minus 1 by y, q is 2y. Now, integrating factor e power integral p dy, because independent variable is y. E power integral minus 1 by y dy, that is e power minus log y, that is e power log y power minus 1, that is y power minus 1 1 by y. E power log x, x, e power log fx, fx, e power log y power minus 1, y power minus 1, that is 1 over y. Therefore, you can write down the solution directly. The solution becomes x into e power integral p dy, x into 1 over y is equal to q. Q is 2y, e power integral p dy is 1 by y. Now x over y, integrating 1 you get y plus x by y is equal to y plus. You can easily verify the solution, because if you differentiate this, you can see that differential equation. If you differentiate this once, right, you can easily see that differential equation. dy by dx is equal to x plus 2y square, or x plus 2y square dy by dx is equal to 1, something like that. So now, this is linear equation x. Now, apart from that, you must know how to reduce the problem to linear type by proper substitution. How to reduce the problem to linear type by proper substitution. That is very, very important for IIT. So, this is IIT type of problem. That is secant square y dy by dx is equal to plus 2x tan y is equal to x cube. Secant square y dy by dx plus 2x tan y is equal to x cube. There are some problems which can be reduced to linear type, by introducing a new variable. We are introducing a new variable now. In the new variable, we are getting a linear equation with respect to a new variable. Independent variable will be x. Let's verify all these things. After giving substitution, you will come to know. So here, differentiating tan y, you get secant square y. So therefore, I am giving a substitution z is equal to tan y, because in the problem you see function and its derivative. If you have sin y, you get cos y. If you have cos y, you get sin y. Like that. We are log y 1 by y. Like that. So therefore, z is tan y, where y is a function of x, because this is a differential equation having x and y. Automatically, y is a function of x. Therefore, differentiating z with respect to x, you get a secant square y into dy by dx, because function of a function rule. I repeat again, z is a function of y, where y is a function of x. Differentiating with respect to x, you get tan y secant square y, again differentiating dy by dx. We have a replacement for this secant square y dy by dx, that is dz by dx. we are having a replacement for tan y. You get x into 2z is equal to x. So dz by dx plus tz is equal to. So divide dz by dx. It's a linear equation in z where p and q are functions of an independent variable x or constant. In this case, both are functions of x. It satisfies all our requirements. That's very important. Once a differential equation satisfies all requirements regarding linear equation, we can start finding integrating factor right in the solution directly. So therefore, integrating factor will be e power integral p dx, that is 2x dx. That is e power x square by 2, you get simply x square. E power x square. Therefore, solution is z into e power x square, e power integral p dx, e power x square. That is equal to integral q. Q is x cube, e power x square dx plus. We are getting x cube e power x. If it is other way, very easy. Now we have to integrate by parts. Let us see what integral we are getting. We are getting substitution in such a way. That's why I told you it's an IIT type of problem. We are getting substitution in such a way. For this integral, we are integrating now. For this integral, we are giving some substitution. That substitution is we write z e power x square integral x square e power x square x dx. What I have done, I am writing x cubed as x square x, so that we can give substitution t is equal to x square, then dt is equal to 2x dx. Therefore, x dx is dt by 2. Therefore, z e power x square integral x square is t, e power x square is e power t, x dx is dt by 2. That 2 I am taking outside the integral sign, because constant can be taken outside the integral sign. Constant can be taken outside the integral sign. So we have to integrate by parts. Now integrating by parts, you get z e power x square half of, well, t d of e power t. We write this as t d of e power t. So we write this as half of t d of e power t. Integrating by parts, uv t e power t minus e power t d of t, that is 1 dt. That is z is tan y e power x square half of t is x square e power. Integrating e power t, you got e power t, you got e power x square plus naught. So this is the solution, complete solution of the given differential equation, in which we have converted the given differential equation into linear type, linear in z, where z is tan y, z is tan. Therefore, this linear equation we can get in any variable, linear equation in theta, linear equation in r, linear equation in z, linear equation in x, y. Once you identify p and q, that p and q are functions of the independent variable of the differential equation, problem becomes very, very easy. Very, very easy. Okay, this is all about linear equation. Now, next comes Bernoulli's. Bernoulli's type. Now, this is nothing but an extension of linear equation. You take a dy by dx. In fact, this is not given in the syllabus, but it will be useful for competitive examination. In particular for joint entrance examination. Q into y power n. Where p and q are functions of x as usual. Where p and q are functions of x. Are constants. Here we are also converting this. We are converting this equation into linear type, provided this y power n is eradicated. Y power n is eradicated. For that, you divide by y power n, you give substitution in such a way, this reduces to linear equation. This type of equation is called Bernoulli's type. This type of equation is called Bernoulli's type. In Bernoulli's type, dy by dx plus py is equal to q times y power n, where y is a dependent variable. Some index y power n, some function of y. You can also get sin y, cos y, e power y, whatever it may be. Divide by that, convert this as a linear equation by proper substitution. So this is called, apart from q, if you have function of y, that function of y to be eradicated. This function, this indifferent equation of this form is called Bernoulli's type. The procedure is divide by y power n and give proper substitution to reduce it to linear equation. That's all. We'll solve one problem in this. Carefully we'll do it and it take it. Consider dy by dx minus 2y by x is equal to y power 3 by x power 3. Oh, don't worry. This is Bernoulli's type. Or Bernoulli's equation. Because we are having an extra function of y. What do you do? First of all, divide by y power 3. 1 by y power 3 dy by dx. 2 by x. Y by y cubed 1 by y square is equal to 1 over x. I repeat again. For Bernoulli's type, anything apart from x as a function of y, you divide by that. If you see some function of y there, it comes under Bernoulli's type. That's all. Divide by y cubed, you get this. Now, you give substitution. Z is equal to 1 by y square. That means y power minus 2. You differentiate z with respect to x. Minus 2 y power minus 3 dy by dx. Or minus 2 by y cube dy by dx. So dz by dx is minus 2 by y cube. Hence 1 by y cube minus half dz by dx is equal to 1 by y cube dy by dx. 1 by y cubed. We are having a replacement for 1 by y cubed divided by dx. 1 by y cubed divided by dx is minus half of dz by dx. So now we are replacing 1 by y cubed dy by dx by minus half of dz by minus 2 by x. 1 by y square is nothing but z. Z is equal to 1 over x. 1 over x. We are nearing linear equation in z. This minus half should be eradicated. Coefficient of dz by dx must be unity. Therefore, now multiply by minus 2. X plus 4 by x z equal to minus 2, therefore minus 2 by x. Now this is exactly a linear equation in z. It's exactly a linear equation z. P is a function of x, Q is also a function of x. P and Q are functions of x. So therefore, we find an integrating factor. As usual, e power integral p dx, integral 4 by x dx, that is e power 4 log x, log x power 4, that is x power 4 according to property of log. If our log fx is fx, directly we can write down the solution. Solution is z plus dependent variable is z. E power integral p dx is x power 4 integral q. Q is minus 2 by x cube. E power integral p dx is x power 4 plus. Repeat again. As usual, we are adding the solution. Z e power integral p dx integral q e power integral p dx x power 4 dx. X cube gets cancelled. Gets cancelled. We are left with only 2x minus sign. Therefore, z x power 4 is equal to 2 into x square by 2. 2 gets cancelled. You get minus x square plus c. Where z stands for, I think we are given z as 1 by y square. Therefore, z is 1 by y square. 1 by y square x power 4 is equal to minus x square plus some constant. This is the solution of the given differential equation, which is of Bernoulli's type. So just understand the type, because usually in competitive examination, joint entrance examination or any other examination, they ask problem under Bernoulli's type, and automatically we give substitution, we reduce to linear, a proper substitution, divide by function of y in the right hand side, and so on. Automatically it is a problem under, it is nothing but extension of linear equation. Anybody can solve and enjoy. So try to solve many problems, competitive examination question paper, enjoy. Thank you very much. Next class we will continue.